Okay, everyone, thanks for joining tonight. Thank you, AJ, as usual, for always helping out and making this happen. So tonight's course is going to be on residential plumbing. As AJ said, we're going to go through a bunch of slides discussing a residential plumbing. So we'll start out with the first slide. Okay, quick background on that's who we are. We're Higher Elevation. We do home and commercial inspections. We're family owned and operated. Those are my two sons that are part of the business. The one on the left is Christopher. He's out in the field. The one on the right is Joseph. He's a finance guy. He does all the stuff behind the scenes, which is a good part of being able to go out into the field and doing our job, not having to deal with the books and all of that kind of stuff. As AJ said, I am an InterNACHI certified master inspector, certified professional inspector, licensed for termites, and New York State continuing ed, and teach the course as well. I have a background in electrical and mechanical engineering. Right. So that QR code, I'm going to show it later. If anybody wants to just take that, and if there's any questions after the webinar when we disconnect, feel free to call me anytime. I'm always around driving. I'll be more than glad to help you guys out. So that's who we are. And next. All right, so we'll jump right in. So introduction to plumbing. The plumbing word comes from the word plumbing comes from the Latin word meaning lead, because early piping systems were made predominantly from lead. Plumbing refers to the installation and distribution of the piping system that carries water and removes waste from a home. That's a great illustration to give an overview of what you're looking at from the plumbing section of it. If you glance at that quickly, we're going to go over all of those components in detail. Residential plumbing, as you can see on the diagram, it includes supply line, drains, vent, and sewer connections. Us as inspectors, we want to understand how plumbing system functions to identify exactly what we're inspecting for: leaks, damage, or improper connections. All of the stuff we're going to go through in detail as we go through. Plumbing's codes change regularly, so we're not code enforcers. So we go out there and we look at the physical aspect of all of the plumbing defects and safety concerns, rather than just, strict compliance code. Next one, AJ. Okay, so when we're out in the field inspecting, we're basically looking for four types of defects. Obviously, one of them is leaks coming from the water supply or anything that's carrying water. Also, inadequate water supply. If you're running water and it's low pressure, that's something that you're going to report on and indicate, as well as water contamination. When we say that, we're basically looking to see if there's backflow preventers and make sure there's no cross connections that allow the drinking water to be polluted. That's a big function of the backflow preventers. Improper installation, incorrectly installed plumbing components can lead to system failure or safety concerns. One of the things we look at when we're doing an inspection is the water pressure. If the pressure is too high, that'll cause a problem at the fixtures because the pressure is too high. A lot of times you'll see on the water main coming in a pressure regulator. Understand what that is. We're actually going to show some of that later. We'll get into a lot more detail, but it's just kind of a quick overview. Us as inspectors, we must identify and report these defects during a home inspection to help assess the property for our clients, that what they're buying, they understand exactly what's going on. Next, AJ. Okay, so when you're out in the field, you're going to follow a standards of practice. Seems like mostly everybody that's an InterNACHI member is going to follow the InterNACHI standards of practice. So some of the things that we look for and to follow the standards of practice is pretty much laid out here. Water supply, the main water supply shutoff valve, main fuel source shutoff valve, water heating equipment, run water on the interior supply lines, fixtures, faucets, make sure it's operational. That's how you're going to determine if there's any leaks. Test the toilets. We'll go into a lot more detail when we get into those. Sinks, tubs, showers. This is kind of an overview of what we're going to talk about. Inspect drains, waste vents, and sump pumps that are accessible. Next, AJ. Also, when we're doing the inspection, we are going to identify whether the water supply is public or private. I got a bunch of slides in here that will show the difference in different areas, what to look for and understand whether it's private or public water system. Basically, when we're talking about public, it's municipal. When we're talking about private, it's a well system. Report the location of the water main. I always find it important to let our clients know exactly where that water main shutoff is. God forbid there's an emergency in the house. Everybody should know where to shut it down. There's a plumbing leak or anything like that, just show them where that is. We state that in our report location. We put a red circle around it. You'll see some pictures coming up shortly. You won't just have to hear me babble, but yes, identify and report the location of the main fuel shutoff. You know, if it's got gas or oil, you want to identify where the shutoff valves are. Note the location of any visible fuel storage tanks, oil, propane. Clearly describe the locations in the report for the homeowner's safety and access, just like we were talking about. Next, AJ. Okay, so going back to what we were talking about, whether it's private or well water. If it's on private well water, you're going to see this type of tank there, because what they're doing is they're actually taking the water from below ground and pumping it up into this storage tank, and then it gets regulated by the tank itself. And then as you're using the water, it depletes, and then the pump goes back on and it fills it up, kind of like an overview. The important thing is to understand, if you go to a house and you see this, you're on private well water. Next, AJ. So again, we were talking about describing the location and the water main shutoff valve. So clearly on this, it's coming through the wall, coming through the foundation. We know that this is municipal water. So water main shutoff valve located in basement. Always make sure that you point it out to your clients so they know where it is. Normally in our report, we'll have this zoomed in, and then we'll have another picture next to it further away to kind of give it a reference. I know some people put location, northwest corner of the basement. Most people don't know, what direction their house is or facing. So we kind of put it in there and we show it to them. That's all part of the inspection. As inspectors, that's what we want to do to identify it. Next, AJ. Okay, that's kind of what we were talking about earlier. Water main located in basement, water main shutoff valve. Again, we identify it. We know it's the water main as well because you see the green wire coming down. That's the ground from the panel. Again, give them a further view away from it. And then, as we talked earlier, part of our inspection is to identify the piping coming into the building. In this case, it's copper, supply piping within the building, which would be, feeding itself out. You're going to see copper. A lot of times you can't see the plumbing going up the wall. So we always include not visible. Again, water main shutoff valve location, basement. That's basically for the water main shutoff with a little more detail. Next, AJ. There you go. Another picture. You just put your hand in there, show them where the water main shutoff is. If you look down on the bottom of the picture on the right, that's the top part of a backflow preventer. We're gonna have some of those pictures in there as well, but that's something that you have to check to make sure you have. I guess I know in New York State they're required, so that's part of the inspection. Next, AJ. Okay, we also talked about shutoffs for the fuel system, whether it's gas or oil. Again, this is a gas meter, and then we zoom in on it, and we on the left hand side, right. I don't know. They can't see my cursor, right, AJ, because you're controlling it to kind of highlight what I'm showing.
Yeah, that's right. They can't.
Okay.
They're not gonna be able to see your mouse.
Okay. So maybe on the break we could try to flip it around. If not, we're all good. So again, the picture on the right is a zoomed in shot of the main gas shutoff. That would help
Oh, give me
identify it.
1 sec. I think I got off the presentation for a second.
Yep.
Hey guys, while I have you on here, while I'm giving this presentation, please use the Q&A in the chat to ask questions, and we'll get to those during the break. I'm gonna also try to figure out how to convert this to an actual PowerPoint. That way I can monitor the chat and all that in real time. But just so you guys know, ask your questions, use the chat, but I'm gonna be using the Q&A during the break to answer questions. All right, let's go back to the keynote. All right. And we were on slide 12, I believe, or was it
Yes.
13?
No. Yeah, yeah, we're moving on to 13. So that's perfect.
Okay.
Good heads up. I guess everybody can see it now, AJ.
They should. Yep.
Okay. If they're not, I'm sure they'll let you know. Okay, so as part of the inspection, we talked about identifying any fuel sources that are on the property up here in the Northeast. One of the big things is if it's a buried oil tank. This house happened to have an existing buried oil tank, and this was the fuel source they were using. So it's very important to identify this for a lot of reasons. Obviously, one of them being an environmental concern if that tank's leaking, which is another whole course and topic of conversation. But our job is to identify location of fuel storage tanks. In this case, it happened to be in the ground. Next, AJ. Okay, so the inspector shall report in need of correction. So now we're getting away from the identifying the fuel sources and all of that stuff. Now we're going to be looking for deficiencies. So in this case, you're going to check the water supply, pressure, run multiple fixtures, see if if the pressure drops, then you would identify it. Again, it's not our job to find out why it's happening. It's our job to find out it's happening and report on it. Could be a multitude of reasons why, but run multiple fixtures, flush a toilet bowl, turn the shower on. If you go out with a two inspection team, if someone's on the second floor, just communicate with them to run the water up top while you're running it down below. Make sure you don't lose pressure up top. We've done a lot of inspections where we're running faucets and fixtures and showers downstairs, and you go up to the second floor, you try to turn it on, there's absolutely no water pressure. That's our job uh, to identify that stuff and report on it. That's really our job, and it's very important. Um, Look for improper installation of hot and cold water faucets. A lot of times they'll have them reversed. They'll have the hot on the opposite side as the cold. So it's our job to identify that because you don't want someone to make a mistake and turn it on and think they're turning the cold water on and it's hot. They kind of switch it around. Inspect the sink, tubs, drains for proper operation. The toilet bowls, you want to make sure that they're attached properly to the floor. The way we do it is we straddle it. We'll straddle it with both legs and just kind of see if it moves a little bit. I know some people they'll lean on it with one leg. I'm concerned that you're gonna wind up dislodging it and creating a bigger problem. So we like to straddle it and then just kind of see if it wiggles a little bit between both of our legs, and then if it does, then report on it as a loose toilet. Um, Yet flush it, watch it as it flushes. If it starts gurgling, you have some type of situation going on, again, just identify the problem, and unless you know exactly what's going on, just it could be a blockage in the line, it could be poor venting, so it could be a bunch of different things that you don't want to uh, say what it is. You just know that there's a deficiency and you report on it. Next, AJ. So that goes back to if you have a crack in the sink, anything like that, you report on it. You're doing visual observation as you're running the water. Look in there, you'll see a crack in the sink, and when we report on it, we put it down as a surface defect. Obviously it's unsightly, but also bacteria and stuff could build up in there. You don't want to have those things. It should be a smooth surface. And then again, location. Going back to report writing, time, task, location, and recommendation. So these are all of the things that you want to put in your report. Obviously, location and then the task. Next, AJ. Excellent. Again, we talked about drain stoppers. You operate them to make sure that it's going to hold the water, the drain's working properly. If it's not, again, we're talking about location. When we report on it, this is how we do it. We say half bathroom sink, drain stopper ineffective. Short and sweet. We like to put our little text overs on there. Same thing. Drain stopper ineffective. And then if you saw on the top on our reports, I cut it off on this one, but we have those location, time, task, and all of that stuff. Next, AJ. Okay, so we were talking about drains. So whenever you look under a sink or anything where you have drainage, and you see this plug, normally this indicates that there's been a clog in the line, and they can't get to it because if you notice, this is all glued, and it's not a good application. So we called it out, and clearly you can see caulking and glue around that bottom ring below the red circle. So this basically what they do is they unscrew that and they'll put a snake in there if there's a clog, because obviously the drain is going through that wall and then down to the basement or wherever it's going. But this is an indication that they had prior repairs on this. So just call it out. Again, there's the location, kitchen sink drain, etc. Next, AJ. Okay, so we talked about distribution pipes, looking for corrosion and stuff like that. This is just a picture of the water storage tank. This was an indirect fired water storage tank, and again, it's simple as looking at it, identifying it, and just stating the fact. Um, it's literally that simple. Just look, and you'll find a lot of things. Just know where to look. Next, AJ. Um, what we like to do is recommend servicing, mechanicals on a regular basis. We talked about we have to identify the age. Some standards tell you don't have to do it, but I think it's an important piece of information for your clients. They're going to want to know. They always ask, what's the age of the mechanicals, water heater, boiler, if it's a furnace or air conditioning, they always want to know. Um, Again, we talked about location of things. This was an inspection we did just recently, and the original cesspool was under the rear patio. They were not using it for sanitary waste, but they were using it for the downspouts and the drains in the back. If you look at the picture on the right, you'll see the downspout going below grade, and then you'll see a drain in the left side of the picture. My concern with this was it was the original cesspool. This house was over 100 years old, so if it was original cesspool, we know it was block or stone or whatever. But they put it underneath the patio, so that's a major problem as far as I'm concerned. So we called it out. We talked to the client, and they're gonna make a decision on what they're gonna do with that. But definitely not a good idea, because if it's an old, cesspool that's being converted for downspouts and drainage, you have a potential for collapse. So we brought that to their attention, and That's, that's pretty much that part of it. Next, AJ. Okay. Also, you want to identify the main house trap. A lot of new houses in our area. I don't know how it is, throughout the country, but they're starting to eliminate the main house trap because they feel it's double trapping because you have traps at the sinks and all the fixtures inside. But this was an older house. They just literally took it out for whatever reason. The house is not, it's not a brand new house. So again, if you don't find that main house trap, just call it out as not visible. And if it's certain jurisdictions where they don't require a house trap anymore, I guess you have to know your local jurisdictions. But if it's not there, we mention it. Um, so you can go to the next one, AJ. That was perfect. Um, so things that we're not required to do as inspectors. If a pilot light is out, we're not going to light it. Simple as that. Um, Determine the size, uh, temperature, age, life expectancy of water heaters. I just said before, I like to put the age in. Again, you can go above and beyond the standards of practice. And I think certain things are important information that you should share with your client because they want to know. We always put this for the water heater, we always put the size in, how many gallons it is. Temperature, I'm not sure what they're referring to on that, but if it has to do with the water temperature at the sink, we we monitor that, and if it's too high, we call it out. Life expectancy, you know, that's a 50-50. That's a flip of a coin. Some people put it in. I don't put it in our reports and inspections because different manufacturers have different life expectancies and how things are used and serviced. So that's a really tough thing to comment on. So that's not a requirement, but I know people that do. Um, Inspect the interior of the flues. It's impossible unless you're up on the roof and you can take the chimney cap off and look down. These are things that you're not going to that you don't have to do. I know some people that do it. It all depends what you want to do. Combustion air systems. If we feel that there's a need for combustion air in the mechanical room for a multitude of reasons, I'll call it out. We just did it today. There wasn't enough combustion air. It was hot in there. It just didn't feel right, and we suggested to further evaluate and just get combustion air in there. It just makes sense. Water softeners and filtration systems, well pumps. Actually, when with the well pumps, you are testing them when you're running the water and it's cycling through. You watch the gauge and see where it fluctuates between the PSIs, and then you can get a good idea. You want to make sure it's not short cycling, whereas you're running it just keeps on clicking on and off. So you can do that. Floor drains, lawn sprinkler systems, and obviously fire sprinkler systems were not required to inspect on it. Not inspect those things. Determine the exact flow rate, volume, pressure, temperature of water supply. Again, it's what your comfort level is. We do check. I mean, it's if it's obvious if the water pressure is low, we're going to call it out. The water quality, we don't test for water quality, although I know some people do. They make that part of the ancillaries, which it's not a bad idea. You offer it up as a secondary service. Um, that's part of it. Inspect clothes washer machines or their connections. We look at it. We look at the hoses when they're attached to the water supplies to it. If they have the old rubber hoses, we like to call them out because they have a tendency to fail. We always recommend the braided hoses to get away from the rubber hoses. Operate any valves. Obviously you don't want to do that because if the valve fails or freezes or something like that as you're playing with it, I that's not recommended. Again, certain things, you don't have to do. We're not required to, but if you choose to do it, certain things you're opening yourself up for problems. Um, Test the shower pan. I know some people that literally let the shower pan fill up and let it sit for whatever 30 minutes and then check um, to see if it's leaking. I think if you run it and make sure it's not leaking anywhere, I think you're in good shape. Um, Enclosures, if it's running, what we do is when we do a shower stall, we'll take, if we can angle the shower head and make it hit the glass doors or something like that, and recreate as if somebody was in the shower and that water was bouncing off the walls, or the glass enclosure. You want to see if it's leaking on the outside, and a lot of times you will you'll see that if you do it. If you just turn the shower head on and it's going straight down, it's not hitting the glass enclosure, it's going to be difficult to see. But again, whatever your level of comfort is on that. Number 10, evaluate compliance with conservation. We're not looking for that kind of stuff. If it's Energy Star rated, you could point it out to your clients to enhance, the mechanicals of what you got. Uh, Proper design for sizing of any water waste, vent piping fixtures. You're not gonna look at the sizing, but you're gonna get indications when you're running the water and flushing the bowls if there's issues with sizing. You'll know pretty much right away. Um, and then inspect water treatment systems. What's important is the comment underneath. It says, make sure if you're not doing something, make sure it's in your pre-inspection agreement, clearly stated out. If you're not doing it, you're not doing it. Let your clients understand. Um, Also, in your report, you reiterate it in your report that certain things weren't tested. You put it in that system uh, section as a limitation. Each system, when you're writing a report and you're going through the inspection, you want general information, limitations, and obviously deficiencies. If you're not doing something, it's clearly stated in your pre-inspection agreement as well as within your report. Next, AJ. Okay, again, continuation. We're not required to test backflow preventers. That's a separate, usually the town or the jurisdiction will do that. Um, we're not going to determine if the existing cleanouts, for the drains are proper. We do want to see cleanouts, especially on the main sewer line. But we're not looking for sufficient amounts. If they're there, if they're not there, then you could make a comment on it. But we don't know what sufficient is because we don't know what's going on behind the walls. Um, we're not required to evaluate fuel storage systems and wastewater treatment systems, which means like cesspools and stuff like that. Again, those are separate. I know a lot of people that do it as ancillary inspections. But if you have an oil tank that's in the basement, you're gonna look, underneath it. Don't touch it. Just look underneath it and see how it looks. If it's rusted, sometimes you could see it's starting to leak. You're definitely gonna call that out. I wouldn't hide behind that on a limitation saying you're not going to you're not going to evaluate it to know that, but you want to clearly see if there's a deficiency. Um, we don't test safety controls. We don't operate the TPR valves, manual shutoff valves. We don't do any of that, as we talked about earlier, because that becomes problematic. Inspectors are not required to test for gas leaks. Um, I know a lot of people have the test, the gas tester. You can, you add on to it if you want. Um, but we're not required to do it. And if you go above and beyond the standards, that's another topic of conversation. But most people in the field do. If you abide by the SOPs verbatim, you're really doing a limited job. You want to do a lot more to give your clients as much information as you can. Solar systems, we know we're not doing any of that, etc. You can go to the next one, AJ. Yeah, skip that because we're not showing videos, correct? Okay, there you go. So now we're going to get a little more into like now these are the fixtures. We talked about it earlier. Now we'll look at it and discuss it a little more. So again, fixtures include sinks, toilets, tubs, showers that are used on a regular basis. Um, we operate the fixtures to check water flow and drainage. That's obvious. If you have low water pressure, you're going to call it out. We talked earlier about when you flush the toilet bowl, if it gurgles and it goes down slow, it might be a blockage. So those are the things you look for from the fixture standpoint. And again, your fixtures are your sinks, toilets, tubs, showers, those kind of things. Look for leaks. That's obvious. We're doing plumbing. That's one of the big things on plumbing is looking for leaks. Um, Check the toilet we're talking about that it flushes properly. Observe the water pressure. A lot of times when you're in the bathroom, you can run the shower, run the sink, flush the bowl. Now you're running three fixtures. When you flush the bowl, if you see the water pressure fluctuate, sometimes it'll fluctuate a lot. Just comment on it. Put it down as an observation. Um, that's good. You can go to the next one, AJ. Okay, so the toilet bowl gets mounted to the floor, and the connections, flanges, and joints, these are all of the things that are making it uh, a mechanical connection to the plumbing system. And as we talked about earlier, we want to make sure that the bowl is not loose. So we straddle it and we kind of rock it back and forth a little bit. The picture on the top left is the flange that the bowl is going to get attached to. Then the picture in the middle is the waxed seal that helps prevent water and sewer gases from, leaking out clearly. And that's just the picture on the right is just another picture of a floor drain that goes into the floor, and then the toilet bowl gets mounted to that. And then obviously underneath is where it's coming through into the basement. And you'll look for corrosion, comment on it, you flush it, it'll be leaking, those kind of things. So that's important to understand how the toilet bowl is mechanically attached to the floor drain. Next, AJ. So when we're observing plumbing, it's important to know the verbiage for it. So in this case, this slide is showing what is referred to as the tailpiece. And clearly the tailpiece is that piece that's coming from the top and it's going into the trap itself. So that's a diagram of it. And if you look on the right-hand side, that's an in the field type of thing. If you notice this one doesn't it has a trap on the bottom, it doesn't have a clean out because you have those two rings that you can loosen up by hand and literally remove that trap. And again, that's a plastic one. Then you have a metal one. So there's all different kinds in there. And when you're inspecting it, you're going to look for leaks, the obvious corrosion, poor connections. As you're running the water, it's going to lend itself to you observing what's going on. Next, AJ. So going back to the water temperature, um, it's important to identify. Obviously, if you turn the hot water on, and you see steam coming out, it's going to be excessive. You want to check the water temperature if you have an infrared camera, a thermal imaging camera. There's a lot of different ways you can test it, but identify it. You'll have a pretty good idea of the water temperature just by turning the hot water on by itself when it starts steaming, and you can tell. Or use something that would identify the temperature, and you can report on it. You could take a picture. Um, must be controlled to prevent scalding. Water at 155 degrees, if you look at the chart, it can cause a third degree burn in 1 second. At 133, 15 seconds, 120, a little bit longer. And then, of course, you want it to be too low because you want to have, enough hot water to clean things and whatnot. Next, AJ. Okay, so when you're inspecting the sink, most sinks have this overflow built in to the sink. So if the drain gets clogged or you run in the water and you close the drain by mistake, it'll overflow and come out the side. We see a lot of new modern sinks that don't have this. So, I mention it to the clients if we see there's no overflow. Um, Again, it's a lot of it's design features, but again, I don't know what local code and jurisdiction is, if it's allowed or not, but these are things you're looking at when you checking fixtures, and then underneath you'll see that piece for the overflow, and it goes right back into the drain. So again, underneath you're gonna check for corrosion, all the obvious stuff on plumbing: corrosion, leaks, improper connections, fittings, that kind of stuff. Next, AJ. Um, Proper clearance is required around the toilet bowls for safe use, and you want to be able to clean it properly. Plumbing fixtures should not block doors, windows, or walkways. That's a lot of the obvious, but if you see it, you're going to report on it. Adequate space, you know, to be used comfortably and safely. Improper placement can cause safety and accessibility issues. Inspectors should note fixtures that interfere with normal room operation. So a lot of common sense stuff. You're out in the field, you see things that you scratch your head and you wonder why. Just report on it and move on. Next, AJ. Okay, so water closets. Water closet is the technical term for a toilet. Sometimes there'll be called water closets. You'll see WC on the door. Toilets are designed to remove waste using water and a flushing mechanism, which hopefully we all know. There are all different kinds of mechanisms. That's an assist. That's another one on the left. Then we were talking about how it's connected to the flange underneath it. So the middle picture is one of the bolts that are holding it down. You want to make sure they're not rusted. A lot of, everything's visual, so you see things and you pay attention and you really take your time and don't rush through. You'll find deficiencies as you move on. Loose or damaged toilet, we talked about that. KAJ, you can go to the next one. Urinals and bidets. Again, visual. Be careful when you test these. A lot of funny stories out there, but just be careful as you test it. Make sure it drains properly. And these are specialty fixtures. You don't see them in houses all the time. Um, Urinals, they usually you'll see them in commercial applications. Everybody knows what a bidet is for. It's for personal cleaning using a water spray. So that's the picture on the bottom left. You could see that water coming up and doing its thing. Inspect these fixtures. Again, proper water flow, drainage, and leaks. That's the MO with plumbing. Um, from this part of the plumbing inspection. Backflow devices such as vacuum breakers help prevent water contamination. We talked about that earlier. That's usually on the supply line and into the irrigation system outside. Next, AJ. Same thing. We want to make sure that that they're properly attached to the wall. That we all know they're used for hygiene, to keep your hands clean and after you go to the bathroom. So you got to make sure you have proper water temperatures. You'll check underneath the picture on the left. You're looking at the supply lines. You're making sure nothing's leaking. Um, Check the surroundings around it. Again, the more you look, the more you'll understand what you're looking for. The supply lines, traps, and connections. Verify the sink drains properly. Again, plumbing and the picture on the right. You want to make sure that it's secured. If it's mounted to the wall, you want to make sure it's secured properly. Next, AJ. Sinks. We talked about that earlier. Kitchens and bathrooms, utility areas. Inspect faucet for proper operation, water pressure and temperature. Check around the faucet base and supply connections. Make sure things aren't leaking. Picture on the right, you can see the faucet's leaking. Again, take a picture, comment on it, put it in your report. That's why we're there. Next, AJ. Okay. Food waste grinders. Um, Same thing. You're going to inspect it. They're typically installed underneath the kitchen sink and it's connected to the drainage system. Again, you're going to inspect for leaks at the connections, the mounting assembly, and discharge piping. You want to make sure that it's operating properly. You can operate it, run the water. Sometimes there's switches, sometimes there's strainers that you have to put in and turn. You'll kind of figure it out, and you listen to make sure that it's not making a lot of noise and it's functioning properly. And again, the only way you're going to operate that system is if it's safe, um, and check for proper function and unusual noises when you run it. Um, Improper installation can cause leaks, drainage problems, and of course, damage the cabinet. If it's leaking underneath the cabinet, you're going to wind up damaging the cabinet. Next slide, AJ. Okay, so the dishwasher, obviously, you're going to run it, you're going to operate it, see how it's functioning, put it on a short cycle. If there's the homeowner's personal belongings in there, we wouldn't run it. So if there is, just comment on it that, you know, people's personal belongings in there, you're not going to run it. But some of the things you look for when you're doing a dishwasher inspection, again, making sure the plumbing's connected and all of that stuff. Underneath the cabinet, you want to see what's called a high drip loop. Some places do an air gap. You can see the illustration. You got the air gap on the bottom picture. There's clearances. If you look on the illustrations up on top, that's where the high drip loop would come in. You want it to come up higher and attach underneath the sink and then loop back down to the drain. So what you're creating is you're creating that high drip loop that if the kitchen sink backs up and gets clogged, it's not going to empty itself into the dishwasher because the loop is going to be higher than the lowest point where it's going to come out. So it'll actually wind up coming out of the sink above it. So if you look at the picture on the top right, that's where you would have the connection for the high loop, and then you'd see the drain is slightly lower, so it wouldn't go back. You wouldn't have that siphoning effect into the dishwasher. So that's important. And again, that's achieved sometimes by an air gap. That's another way of not having it back up into the sink. Um, that's the dishwasher. Okay, you can go to the next one, AJ. Again, the dish. I'm sorry, the clothes. The washing machine for the clothes. Um, requires both hot and cold water supply. You got to check that. The picture on the top, you can see you have a hot and cold shut off valves. Why they're both red, I don't know, but usually one's red and one's blue. Again, the picture on the left, that's the standpipe. It goes down to a trap. That's an actual picture of it. Then if you look on the right, that's how it's designed to drain the clothes, and it's going into your waistline, just like a faucet on a sink, that kind of stuff. But I think the next couple of slides we're going to talk about the size because there's a good amount of water that comes out. Now, a lot of times you'll see the washing machine discharging into a slop sink. Some jurisdictions it's okay, they allow it, but my concern is that the drain in the slop sink is a lot smaller, so you have a tendency of it to clog up, and you have to worry about lint and stuff coming out of the clothes and the soap. Sometimes that drain gets clogged up and it can overflow. With the standpipe, it's a much bigger drain, and it's going out and it has a trap on the bottom. So it's a much better application. We always discuss that with the client. If the washing machine is discharging into a slop sink, we just have that conversation and we state the fact that it's discharging into the slop sink, and we talk about and document a couple of potential issues without having a standpipe like this. Next, AJ. So the picture on the left, you can see the washing machine hose is going into the slop sink for drainage of the washing machine. Um, it's there. Another problem and concern is that if that hose is not attached properly to that slop sink, when the washing machine discharges, there's a lot of force there, and that can dislodge itself from the slop sink. So if that's the case, we recommend to the client that they secure it to the sink properly. When you're in the standpipe, they have, mounting brackets and stuff to keep that in, so you don't have to worry about it popping off. Plus you're going into the drain, so the drain itself, that end piece of the hose is going to go into the drain, and it's going to help, keep it from popping out. Again, that's a slop sink. That's an older cement slop sink. I would be concerned with the proper drainage, with the dishwasher. And if somebody's running the faucet, just, today's standards. This is a roughed in. They're gonna attach the washing machine to this PVC pipe on the right hand side. It's what it seemed like on this, that they're getting it set up for a washing machine. Next, AJ. Bathtub, shower stalls. You want to check again for cracked and damaged surfaces, um, properly supported. You want to inspect the caulking around where the tiles and the tub meet. We like to tap on the lower tiles. If there's damage, you'll hit them, click, they'll move. You can touch them. Just give it that tap. If it's solid, you'll hear that solid thud. Sometimes you'll hear a hollowness behind it. So that's important. Again, the picture on the upper right hand side, you can see they repaired the grout with some kind of quarter round tile, but whatever. You just want to make sure that they don't have a lot of mold buildup and that kind of stuff. Test the drain to ensure proper flow and no slow drainage. If there is, you report on it. Run the faucets to the shower, check for leaks and proper reparation. We talked about that earlier with the glass enclosures. Run the faucet, inspect accessible plumbing connections for leaks. So a lot of times if you're in the basement, you can look up and you'll see the bottom side of the tub, the shower stall, drainage going up. If you have that opening, it's a good time in the basement to look up, and you can see a lot of things going on. You'll see the drains, you'll see the vents, you'll see the supply lines, you'll see the shutoff valves. Sometimes the ceilings, even if you're on the first floor and you have a bathroom on the second floor, obviously you're not going to have this advantage from the first floor, but in the basement you can. You spend a lot of time in the basement, and if things are open like this, it's a good spot to observe your plumbing from above. And then obviously, with us, we go out as a two inspection person team, and someone, it's in the basement, someone's running water up top. I can't tell you how many times you literally turn something on and it just pours into the basement. So you have to be careful if you're out there by yourself. You're checking the plumbing. You're running it for an extended period of time. If there's a problem down below, you might cause a flood. So I know some people, they'll just turn it on real quick, run downstairs, or just start in the basement and look up. It's tough because you're trying to be in two places at the same time. So you have to approach that with some thought there. You can go to the next one, AJ. Okay, Whirlpool tubs and the jetted tubs. Um, we fill it up and we run it and test it. If you're not going to do that, then put it down as um, something you're not doing. We do it. We fill it up. Uh, when you do, if it's the jetted tubs, just make sure the water level is above the jets. Otherwise, you'll be taking a shower at the same time you're testing the jets. You got to make sure they function properly. A lot of times with these old jacuzzi tubs, people haven't used them in a very long time. And if you fill it up and you turn them on, this nasty black gunk comes out. So if it's an older style jacuzzi tub or jetted tub and it looks like it hasn't been used in a while or just doesn't look right, you might just want to put it down as not tested, because if you run it and all of that gunk comes out, you're going to be in there trying to clean that tub for a long time. The jetted tubs or whirlpool tubs, you want to make sure that they have access to the motor and the pump. A lot of times they install these things and you have no access to any of these pumps and shutoffs, and usually underneath there they need electric for the pump. You want to make sure that there's the proper GFCI protection, um, that that kind of stuff. You can go to the next one, AJ. Shower. We had talked earlier about moving the shower head and letting it hit the glass enclosure. It's the only way you're going to create it from leaking on the shower on the bottom. This is the shower pan we talked about earlier. What they'll usually do is before they complete the shower stall, they'll do a leak test on this. They'll fill up the base, they'll plug it, let it sit for a period of time. Again, that's all what they do to pass plumbing inspections. So that is basically a shower stall. We can go to the next one, AJ. Uh, this is exactly what we were talking about. You're gonna take the handheld and spray it on the glass doors, so you'll see if it's leaking from the outside. If you're just running it straight down into the floor drain, it's not going to really help. Also, you want to make sure it's sealed properly. When you close the door, nothing's leaking from the inside. So that's what we're referring to by glazing. You want to make sure that everything's waterproofed. Next, AJ. Floor drains, trenches. You want to make sure that they're not rusted over and clogged and dirty. If they're drains that are on the outside of the house, we always comment on keeping the drains clear of debris so it doesn't back up. You want to see the locations. Some basements have floor drains. You got to check it out. Go to the next one, AJ. Okay. Water supply. This is an overview of fixtures and what usually the minimum size for the pipe is. This is just, FYI information. Water supply pipes deliver water to plumbing fixtures throughout the home. Different fixtures require minimum pipe size to ensure a proper flow. This is kind of, just an idea of what it is. And again, you're not going to talk about the size of the pipe. If there's a problem with the water flow, you're going to identify it and just say improper water flow. You're not going to call out the improper size of the pipe. You don't know what it is. You just know the fact that it's not the proper water pressure. Inspect supply lines for leaks, adequate size piping. The right size piping is going to maintain the proper water pressure. So that's um, that's important. Next one, AJ. Okay, so now we get into water heaters. Most residential water heaters use insulated tanks, and you'll see on the outside it'll say glass line, that kind of stuff. Um, the lining helps prevent the tank from corroding on the inside, as well as the sacrificial anodes, which most people don't know about. Um, Water heaters, they heat and store water. It's different than the tankless on demands. Um, and as we go on, we'll look at 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 those differently. Um, they heat and store water for sinks and showers and tubs and that kind of stuff. Uh, Typical residential water heaters have varying life expectancies depending on use and maintenance. That's why we were talking earlier about it's hard to state life expectancy, because if you state it and maybe the mechanical device or the water tank fails sooner, and then the client say, but you said it's going to last X amount of years. It it didn't last as long. So, you know, you just don't know. We do not state expected life expectancies. A lot of times on the water heaters, that they're actually, there's stickers on them that'll, on the older ones, that they'll tell you about it. Again, when you're looking at the water heater, we're gonna actually get in on the next couple of slides, but um, you want to check the extension tube on the TPR valve. You're never gonna test the valve. You don't want to. Again, we talked about not testing valves. Just overall appearance. You look on the bottom. Visual evidence of rust, leaking, that kind of stuff. Um, you can go to the next one, AJ. Um, some water heaters, they're used for dual purposes. They'll supply hot water to heating spaces. They'll actually run a pump off of the water heater and then just kind of do a loop with hot water underneath. It's not really the most efficient way of doing it, but you see it. Um, and it's on a thermostat. They'll take it. They'll use it as a space heater. Um, the system must be protected from the potable water. Um, Chemicals must never be added to the system connected to the potable water. So, yeah, it's not the most ideal situation, because you can get contamination because you're putting it through the the piping to create hot water, but um, you see it. Next, AJ. All right. So this is the sacrificial anodes we were talking about. Obviously, the one on the top is a newer one. The one on the bottom is doing its job. It's um, Sometimes you'll get electrolysis or corrosive action. This will absorb that, and literally, that's why they call it a sacrificial anode or sacrificial rod. If anybody has a boat, when you put your zincs on the bottom of the boat to keep it from attacking the metal components that are under the water. That's basically the same thing. Um, the zincs that you have on the bottom of the boat, they disintegrate over time because they're absorbing in this case the electrolysis in the marina. But with the water heaters, you'll see these. If you look at the top of the water heater, there's little plugs, and usually, or sometimes they're not, and you'll see the top of the rod where the nut is. Sometimes you have to put a tool in to take it off, or sometimes these are above. You'll do it with a wrench, but yeah, though that's the idea with those. It helps prevent corrosion inside the water heater. It attracts corrosive elements in the water instead of the tank liner itself getting deteriorated from that. Common materials that we're looking at on the anodes are magnesium, aluminum, and zinc. Over time, the rod will deteriorate and should be inspected or replaced if needed. One anode rod can shorten the lifespan of the water heater. So again, back to that life expectancy. If you don't do these things, they can potentially fail sooner than later. Next, AJ. All right. So when you're maintaining a conventional water heater, um, you'll see a drain valve on the bottom. That's all part of the servicing of the water heaters. Um, Again, manufacturer's recommendation, they might say every year, every 2 years, whatever the manufacturer's recommendation is. But usually what happens is you'll attach like a garden hose to that drain, you'll screw it on, and then divert it to a floor drain or outside or some way. The whole idea is to open that valve, and all the sediment that's on the bottom of that water heater will hopefully um, will allow you to drain the sediment, because don't forget, inside you have the water and all the minerals, and you are going to get possibly some, as the tank gets older, it starts to deteriorate and gets flaky. You'll be surprised what comes out of those valves when you do this service. Or you have a plumber or somebody, a mechanical guy, do it for the client if they're not comfortable with it. But this is all part of servicing these water heaters um, to keep it running properly, and try to extend the lifespan of the devices. We go to the next one, AJ. Okay. So water heaters must be accessible for inspection, maintenance, and repairs. If the water heater's in a tough location or a spot that you can't access it and maintain it, that's part of your job to report on that. Um, Sometimes access might require removing a panel, a door, or a similar enclosure. Just call it out and mention it to your clients. You want accessibility, should not require removing permanent building materials like a wall. Um, a lot of times you'll do inspections and the oil tank in the basement is behind the wall. You can't inspect it. It's impossible. They might have a little access hatch on the top just to read the gauge, but again, those are things you're going to call out. Limited, no, not accessible. You got to put that in your report. Again, when you're writing your report, that'll go underneath the limitation section. If everybody's familiar with when you write a report, you state the general information, which we talked about in the very beginning of the presentation. You want to describe what the things are and where the locations are. Then if you have a limitation where you can't get to something, that would be the second part of your report writing. Inspection limitation. State the fact. Oil tank behind a wall, no access. You can't look underneath the tank to see if it's leaking or rusted. So that's important to do that. And then obviously the third part of your report writing is going to be your recommendations and observations. What did you see? Report on it. Again, time, task, location, and implication. You want to do that to uh, let your client know, because then you have to take a wall down to remove the tank, or even just inspect it. You want to know what's going on. So accessibility is important. Adequate space should be provided to safely reach and service the unit. Again, we've been uh, talking about that. Walkways or platforms may be needed for safe access and working condition. So what we're talking about that is um, like certain mechanicals are up in the attic. Um, Sometimes you have furnaces and air handlers up there. The point that we're making is that there should be an easy walkway and path to get to those uh, mechanical devices, and properly lit. Um, that kind of goes off a little bit on a tangent for workspace area, safety kind of stuff. Um, so yeah, just that's the point of that. Walkways or platforms um, may be needed for safe access and working conditions. So you have to make everything accessible. Don't pile stuff up in front of the devices. You can go to the next one, AJ. Okay, so now here we're back to that description part of it with specifically a water heater. So water heaters, boilers, air conditioners, they're all going to have data plates, data tags. And just by reading it, you're going to get a lot of information from this. So the one on the left, it's an electric water heater. Um, Another electric water heater. Uh, then you have an electric storage tank. And then this one's a storage tank. There's a lot of information on this tag. Um, Actually, AJ, if you go to the next one, it's a closer up shot. There you go. Perfect. Thank you. Um, let's spend some time on understanding this tag on a water heater. So we know that this is a storage tank. So if you're looking at a water heater, it's not going to have a fuel source. It's going to be a storage tank where your hot water is going to be getting supplied from another um, device, like whether it's a boiler or a tankless water heater. Sometimes they'll put it into a storage tank for more, more volume. As we go through, we're going to look at some boilers where the coil in the boiler is just, corroded and rusted, and you're not getting that flow of proper hot water. So they bypass that and they'll put it into this storage tank. So the first thing, if you notice, there's a number on this tag. It's called the ANSI number. What that number is, it's telling you that this device was modified at some point. They did something. They changed something on the manufacturing of it. So if you look at the end of the ANSI number, you're going to see 2017. So that's telling us that in 2017, this water heater, storage tank, or any mechanical device was modified. So by us looking at that, we're going to know right there, the 2017, we're going to know that this tank is going to be no older than 2017. And if you look at that 2017 and then you slide down to the bottom right, just above the QR code, you'll see the date built, February 22nd, 2019. Again, you see the 2019, the 2017. We know that this system cannot be older than 2017. So good pieces of information, because sometimes you're going to go to a water heater and the date and the serial number and all of that's going to be rubbed off. So what you want to do is, if you could see this number, you can state the fact that, water heater is appears to be this age, or you can reference that ANSI number. It's not going to be older than that. And every time they change something, they're going to change that ANSI number. So that's a good piece of information. So if you're looking at the tag, you have a model, number, you have a serial number. A lot of water heaters, they're not going to be this, foregoing with the information on the manufacture date. So you have to decode it. So we use an app. It's called Building Intelligence. If it's a free app, if you download it, you can go into it. It'll give you dates for water heaters, boilers, heating devices, and you go by the serial number. So this one follows suit. If you notice the serial number, it starts with 19. That's usually an indication of the year, but it would be verified through the building intelligence I'm gonna tell everybody now. Be careful with ChatGPT. This is one or AI. This is one of the areas where you can get jammed up because a lot of times it makes a mistake. But if you go to building intelligence and you download that app and you navigate it and you know how to use it, it's going to tell you because sometimes on the serial number, it's not the first two digits. It might be the third and fourth for the year. Or Bradford White, a lot of those manufacturers, they put letters in there. They're coded. So you have to know how to do that. You can even go to their website. But Building Intelligence is a really good app. If you go to we have an iPhone, so if you go to the App Store, you'll be able to look at that. Very very helpful in the field. Very 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 helpful. Um, let's see, anything else on here that we need to know? You'd be surprised if you scan the QR code. It gives you a lot of information about the water heater or the storage tank. Um, and I tell my clients all the time, if you see a QR code, it'll give you the manual, those type of things. But what else? And obviously the capacity, we know, right on the top line, you see the 40, and it's natural gas. So this tag gives you a lot of information when you look at it. There's tags on the boilers, there's tags on the water heaters, air conditioning. Understand these tags because you want to document that. We can go to the next slide, AJ. So now we go to the tankless water heaters. This is a picture of it with the cover off in the field. Um, you can uh, you can see the cover off. There's a bunch of brands out there. Um, a lot of times the data plate is inside the cover, so when you take it off, you'll see it. Um, Go to AJ. Go to the next slide. Might be okay. But back to the label again. I don't know. Those slides were a little. Um, we'll go back to the water heater label because I think it's. Don't worry about that, AJ. I know we got another slide that'll get more into the tankless. But again, now we're looking at the tag. These are great tags because you can see the manufacture date right there. It tells you it's easy. It's telling you the gallons. It's telling you it's a natural gas. So again, fuel source. These are things you identify as part of your inspection on the plumbing side. Serial number. Um, it's interesting because if you look at this serial number, if you notice the manufacturer is 05. If you notice this one, it's the third and fourth digit as the year. A lot of times they're not, the manufacturers aren't that nice to give you the manufacture date. You have to decode it from the serial number, or if the manufacture date's rubbed off, you could look at it. So we know it's a 50-gallon water heater. And again, if you look at that ANSI number, now it's on the bottom. You see the ANSI Z21.10. Just go all the way across. The last four digits, 2002. So we know that there was a modification on this water heater in that year. So from this point forward, the water heater is never going to be older than 2002. And clearly you can identify that as we're looking at the manufacture date, we see it's 05. So again, good information for you to know when you're out in the field to share with your clients and put it in your report. You can go to the next one, AJ.
Hey Rob, before we switch to the next slide, can you show what that building intelligence app that you use so they can see what icon it is
Sure.
for anyone that's trying to download it?
Let me see. I have it on. How would I share it with you on my phone, AJ?
Just
Um,
show us the app and just put it up to the camera.
okay. Let's go back.
Is it an app or a website?
Actually, yeah, I think you have to put it as a website. You're right. But I
Okay.
have it on my phone. If you look here, it's on my phone right there. See that one?
Oh, okay.
But you're
I'll see if
right.
I
It
can find
might,
it.
yeah, it might be a website, and then you could put the icon on your phone. Good point, AJ. If it's on my phone and I have an icon, I think it's an app. But yeah, that's a good point. And I would definitely suggest. Uh, Thanks, Saul. You can download it and then have it on your phone as an app. So all you have to do is click on it instead of going to the website. Yeah, and just get used to using it. You know, if you have old reports, open it up to the data plates for boilers and water heaters, and just kind of play around with it. It a lot of good information. It gets a little tricky. Um, on certain things, but just get familiar with it so where you're not wasting time in the field, or just take your data picture and then come home and decipher it, because sometimes you can get stuck. And don't forget, if you're on your phone and you're in a basement, sometimes you have no reception. You can't do any of this. But again, take your pictures, put them in your report, however you do it. Yeah, the building intelligence app is building.center.org/. If
Awesome.
um Yeah, Saul just put it in the chat, I believe.
Yep,
So
it's in the chat.
yep. That's great. Thank you. Yeah, everybody has it on their phone, so it's good. And then again, it's on the website. If you're home writing your report, you can reference it. Again, I can't emphasize, be careful with, Chat GBT and AI. They get these things wrong quite a bit. So just be careful with that. Um, this is an illustration of the tankless water heaters on demand. Clearly, it's very different than the water heaters we were just looking at. Um, Very sophisticated. Um, um, they got electronics. Um, it's lot more involved. It's very, very, very important to let your clients know that these systems need to be serviced annually. They have to be descaled, again, because you don't have a big 50-gallon water heater. This is very different. There's electronics in there. There's filter screens that have to be cleaned. It, they're great systems, but they got to be maintained. Water heaters, they're forgiving. We know I know water heaters 15, 20 years. They never changed the sacrificial anode. I'm like, what is that? Oh, but they're running. So, you know, it's luck of the draw. You just kind of be more involved. When you come across these systems, again, just highly recommend to your clients that they get these things serviced um, on a regular basis. Usually, the manufacturer's recommendation is once a year. Um, you have these systems, they run a solution through it with a pump and a bucket, and it just circulates through, and it uh, decalcifies the interior workings of where the water's flowing through. Because a lot of areas the water is not the greatest. Is You get a lot of minerals and oxidation, so you want to definitely clean clean that up. As a good recommendation for your clients. So with the you're not storing in this system, remember, you're not storing water. You're just heating it up um, within as you use it. So the difference is, on a water heater, you're maintaining that water temperature. So even if you're not using hot water, the water is going to get cooler and it's going to click back on and start heating it up. So that's important to understand. You're not storing water in this system. It's just goes on, it goes through a heat exchanger, and you can see on the illustration, you got the primary heat exchanger. That's where all the heating goes on. So you can clearly see that's a much smaller area than a water heater that you're keeping hot at the temperature you want. Um, Yeah, a little more sophisticated because now you got fans and air inlets providing combustion air and exhaust flue gases safely. What's nice about these systems is you direct vent them, so they go out the side of the house. We're gonna get into venting system after that, but it's different. You don't vent these through a chimney anymore. It's sidewall vented. I'm sure you've seen it when you're out in the field. You'll see them outside. Usually PVC, but you can go to the next one, AJ. Um, this is exactly what we were just talking about. So now when you have these systems, there's different kind of venting options. It's important to understand what they are um, with with the venting. And if you're doing your exterior first, for your exterior inspection on the outside, you're going to see these vents coming through the wall. And a lot of times you'll be walking with the client and they'll ask you, "Oh, what's that?" Just know what it is. In this case, on this one, it's the concentric venting configuration where it's one pipe and the air is exhausted. The flue the gases are exhausted with the red arrow. If you see the way it's going up and through, and then there's another tube within it that is drawing air back in and giving combustion air to the tankless on-demand water heater, and then it goes through that type of system. The other kind are it, and I'm pretty sure we have a slide for it. It's independent. You'll see an air intake and then an exhaust. And again, that's all installed as per manufacturer's recommendation, heights, distances, all of that stuff. But you'll look at it and you'll see it. Two ways to vent these systems. One is this way with the single pipe, and the other one is side by side. One's going to be a fresh air intake, and the other one's going to be the exhaust. When you're looking at these exhaust systems, you want to make sure they're not exhausting next to another appliance, especially next to an air conditioning, because this is dumping, hot flue gases out or warm flue gases out with moisture. You want to make sure that the location of the venting is proper. Venting configurations may vary on installation. We got that. Yeah, we basically covered all of that. You can go to the next one, AJ. So on some of these tankless systems, they use a recirculating system. The recirculating system provides faster hot water at the delivery to the fixtures. So you can see on the diagram how it's done. This is installed on the unit, and it's just recirculating the water. So when you turn it on, it's there for you. Because a lot of times these systems, if they're in a big house and they're far from the fixture, it takes a long time for it to get hot water. A dedicated return line allows unused hot water to circulate back to the heater. So you can see that on the blue line on the bottom. A pump and flow monitor helps maintain continuous hot water circulation. Again, so you have it at the faucets and fixtures. Um, check valves prevent water from flowing in the wrong direction. You'll see that in the diagram. You'll see check valve right there. Flow monitor. So there's a different configuration where, as opposed to just supplying hot water to the fixture, you're keeping it in a loop so you have it pretty much relatively quick when you turn on the fixture. We talked about that. Check valve prevents water from flowing in the wrong direction. These systems reduce wastewater by minimizing the wait for hot water, which is a big thing today. Obviously, water conservation, energy conservation. So if you're waiting a long time for the hot water to come on, you're basically wasting all that water for no reason. So you do this and you're getting hot water much quicker. You're not running it and wasting um, hot water. Go to the next one, AJ. This is a system that's mounted on the outside. Up here in the Northeast, they're never mounted on the outside. Um, they're always inside, and in this case, you're not going to really, it's outside, so it's a totally different application. But again, you want to verify proper venting. Um, Gas odors require, obviously, if you smell gas, immediate attention. Um, Factory settings normally limit water temperature to about 120, 125 to prevent scalding. Um, yep. You don't forget, you have electric on this system now, where your water heater really didn't, unless you got a power assist vent. But these, you have to make sure they're grounded properly, because there's wiring in there, just like every other appliance that needs proper grounding. You're going to have the same situation here. You can go to the next one, AJ. We're not doing video, so you could add. There you go. Great. Um, so when we were talking about the storage tanks, if you don't, and a lot of people, especially if you're new in the field and you go to a house and you don't see a water heater, it's like, where are you getting the hot water from? That's the purpose of this slide. Um, if you don't have a water heater, you're going to be creating domestic hot water through your boiler. So this is what we're talking about here. Inside that boiler, you're going to have a coil, and we have great pictures as we go along. But understand the what you're looking at with the coil inside the boiler. So that boiler is going to click on, and there's a series of coils. It's going to heat up the water. Um, so you see on the illustration on the bottom left, you're taking cold water in, the boiler's clicking on, and then it's coming out, and you get, we refer to domestic hot water, which means you're going to have it at your sink, your shower, anything where you need hot water, your dishwasher, your washing machine. Um, that's how you're going to get hot water from a boiler. So if you go into a house and you're down the basement or wherever and you don't see a water heater, just understand that there's going to be a coil in the boiler to give you domestic hot water. And then, of course, they're using this to heat the house as well. Um, so the tankless boilers, hot water supply demands on the boiler operating. So realize, summertime, the boiler is going to click on to create hot water for your domestic hot water. Um, People don't realize that because you don't have a water heater, and if you're running hot water in the summertime, your boiler is going to click on. So just let your clients be aware of it. You don't have the fact that the coils in the boiler, you don't have a separate water heater. So just food for thought when you're with your clients. Just hey, your boiler's going to click on in the summertime, not giving you heat in the house, but giving you hot water at the taps. Um, Circulator pump. Uh, yep. So this is just a basic schematic. There's a lot more in there with tempering valves and all that. This is just a kind of overview of what's going on. You can go to the next one, AJ. Okay, so now this is in the field. The diagram before was just kind of an illustration. Now, when you're looking at a boiler, the circle on the left, the picture on the upper left-hand side, is that coil that we looked at in the illustration. Um, Various ones. This one's on the boiler. This is another one, the one with the black plate. These are the ones, and you can see from the illustration, you have cold water going in. It goes through the coil. The coil goes all the way to the back of the boiler. It's a series of coils. the boiler clicks on. It's like heating a pot of water up to make tea or something. Same concept. The boiler clicks on, creates heat, goes through the coil, goes back out, and goes to your fixtures. A lot of times you'll see this system rusted, old, corroded, calcified. Remember, some of these boilers, they have 50-year life expectancies, 30 years. Most of the times these coils don't last that long. So what happens is they calcify over time and you start losing water pressure on the hot water side. So what you'll see is they'll cut these pipes off, cap them, and then just run these pipes to a separate water heater to generate domestic hot water. Also, a lot of times, if they don't do that before they find that they're having a problem with the not having enough water, they'll put a storage tank. So they'll put a 50-gallon storage tank, and then the boiler will click on, and it'll be stored in a storage tank where it doesn't have to. It can keep up with the demand. So you'll see variations. If you're looking at the tank to the right and it doesn't have a fuel source, you read the label, it'll say storage tank. If you look at a modified boiler, because the coil wasn't working, you'll see it cut off and capped, and it'll be going to a separate water heater to make domestic hot water. So again, the picture on the left, boiler with a hot water coil in it for domestic hot water. And while we're at it, you'll notice on the bottom the red box. So this would be an oil-fired boiler. Again, we have to identify the fuel source for these systems. So this one, that red box, you're gonna know it's an oil-fired boiler. So those are things you're gonna document on your report for fuel source. If you remember in the beginning of the presentation, we talked about it's our job to identify the fuel source and let the clients know. So again, oil-fired boiler. We can go to the next one, AJ. Okay. So depending on where the water heater is located, a gas-fired water heater installed in the garage are typically required to be elevated for the reasons right there. Conventional units must be at least 16 inches above the garage floor. This helps prevent flammable vapors from igniting. Gasoline, from a car or chemicals. You have that, you have that space where you don't have, it's not along the floor where these fumes can tend to be heavier, and it can be ignited by the water heater clicking on. Modern water heaters, and I can speak from experience on this one. They have what's called an FVIR, which is a flammable vapor ignition resistor. It's on the bottom of the water heater next to the gas valve and stuff. What that's doing is, if it's sensing any kind of vapors, gas or whatnot, it shuts the system down. It doesn't let it ignite. I found out the hard way because we have an older foundation and we scraped and painted the foundation, because it was kind of getting that efflorescence. So we cleaned off and painted it. And we didn't realize that the vapors from the paint caused the FVIR to sense vapors, and we didn't have hot water. Couldn't figure out why. I didn't even know we had this system on it. But we actually had to had to replace that part, because it's like a fuse. The old fuses, once they go, they're gone. Yeah, we had to replace it. So Again, that's just getting you familiar with, that type of system. You'll see it. You really have to look on the bottom and underneath to identify what it has. And that's on old, the modern water heaters today. Um, so understand that if it's in the garage, it's going to be elevated, and usually there's ballards in front of it to protect it, from getting damaged by the car or something like that. But you can go to the next slide, AJ. Confined spaces. Okay, so confined space and combustion air. Gas appliances in confined spaces require proper combustion air openings. We talked about that earlier in the presentation. How you call it out if it's not adequate combustion air or makeup air. A lot of times you'll see, and you could look it up. It's called air in a can or fan, air in a fan or something like that. When you go into a boiler room, you'll see it on the bottom, and it's wired to the boiler that when the boiler clicks on, it's drawing outside air into the utility room to have proper combustion. Um, so you'll see those. And again, these are things that you don't see a lot, but if you come across it, you can identify it. I think it's called fan in a can. If you taking notes, just look it up and get familiar with it if you come across it, especially for the first time if you're not familiar with what it looks like. Um, Openings must be sized based on the BTUs of the appliances, which is pretty straightforward. Combustion air can come from the inside of the building or directly from the outdoors. If it's coming from the inside of the building, it has to have a space where it's bringing in fresh air, because you don't want to bring in air to the utility room from the house, because then you're just depleting the oxygen, and you're creating carbon monoxide. So you don't ever want to do that. You want to bring it in from the outside, and it doesn't have to be tremendously big. Or you could do the fan in a can, where when the boiler goes on, it brings in fresh air at that moment in time when you need it. But that's insufficient combustion air can lead to poor combustion and dangerous carbon. We just talked about that, so that's a good one. We can go to the next one, AJ. This is regional. Obviously, California, certain areas need it. Um, we're starting to see this up in the Northeast. Not a lot, but we see it every now and then for, I guess people are concerned that if they're going to have an earthquake, these things are strapped in, but you don't normally see them up here in the Northeast. They're not required yet as part of a requirement, but the whole idea is that secures the water heater to prevent tipping during an earthquake. Um, Two straps are typically installed in this configuration. You'll also see flexible. If you see on the illustration C, it's a flexible conduit piping. Obviously, if it's going to be shaking and moving during an earthquake, you don't want to have a rigid connection, because obviously you'll wind up with a problem with a gas leak. So, yeah, seismic bracing is required in many earthquake-prone regions. So that's that's good. You can go to the next one, AJ. So when we're talking about water valves, um, you're gonna have them at the shutoffs with the cold water supplied to the water heater. Um, so that's something you're gonna look for and identify. And I see what you're doing, AJ. You're trying to gauge it, eh? All right, I got you. Um, you can go to the next one. That's the dip tube inside the water heater, cutaway view. It directs incoming water to the bottom of the tank. Whenever you're supplying cold water to a water heater, you want it to go to the bottom, and that's what we're showing here. So that's the dip tube inside. Next, AJ. Fuel shut off. You want to identify the fuel shut off. Um, uh, and well, we have a disconnect switch. If you have electric water heater, your fuel shut off is going to be a circuit breaker. So you'll identify the electric water heater. Awesome, AJ. You'll identify the water heater as the fuel shut off for that. So gas, you're going to have a valve. An electric water heater, you're going to have a circuit breaker. So if everybody's wondering why is there a circuit breaker in the plumbing course, there you go. Next, TPR valves. Um, they're there for a reason. It senses the temperature and pressure. If there's an excessive buildup, it it opens up and releases the pressure, so the water heater doesn't explode. Real simple. Never, ever, ever operate that. Don't test it. Don't touch it. Just look at it, identify it, make sure it's got the extension tube that's 6 to 12 inches off the ground for safety reasons. If somebody's in the room and that thing goes, you don't want them to get hurt. Next, AJ. That's the discharge pipe on the TPR valve. An illustration that's coming down from the slide prior. That's the extension tube that's coming down. Very simple without getting into too much detail. It's a safety feature. You want to make sure it's on there. And if it's not, call it out. Next, AJ. Expansion tank. Um, you see these on water heaters. They're designed because as you heat up water, it expands. So if you look at the expansion tank, right in the middle, you're going to see a welded seam. There's a bladder in there. So what happens is, as the hot water expands, it pushes down on the bladder. Remember, you can compress air, you can't compress water. So it pushes itself down, it compresses the air, and it alleviates uh, that expansion. Back in the day, pipes used to knock and ping and all of that stuff. So they put that on, and it eliminates it. Next, AJ. Um, Catch pan on the bottom of the water heater, especially if it's up on the second floor. You want to make sure that it's protected. If there's a leak, you know, a slow leak, obviously, if the thing breaks, it's not gonna. If the water heater goes, it's not going to catch it. But at least if there's any water coming down, like condensation or anything small, it'll catch it into there. Next, AJ. A little while. If you're hungry, eat. Um, the water heater and boiler defects. Inspect both electric and water heater for common component defects. Again, your electric water heater and your gas water heater, you're gonna check for connections, leaks, corrosions, verify the TPR valve, pretty much everything we've been talking about. Inspecting make sure it's vented out properly. You're going to look at the vent connector on the top. You're going to see how it connects into the chimney, or if it's going outside as a on-demand system, you're going to check that as well. You go to the next one, AJ. Skip it. So now potable water, general comments, potable water is the safe. You're going to hear that term potable. It's basically referring to safe drinking water. EPA sets standards. Again, somebody mentioned about water testing. You could do it as an ancillary. It's great. Figure it out. Also, you can ask the water company I'm pretty sure they're required to test the water annually. So that's just a definition of potable. You can go to the next one, AJ. Now we're talking about the private wells. That we have areas by us that there's no public water, so they have a well. So they have to go down. They have to put a pump. They have to pump the water up, and it goes into those blue tanks that we showed earlier. They store it, and then it's a whole cycle. But this is just a cutaway view of what a well looks like. Next, AJ. When you're out in the field, you're going to see this is where the well pump is. So that's the access point. If they have to change it, this is the top of the well casing, and they drill the well to get down to the water in this area, and that's when you're out in the field and you see this in the ground, that's exactly what it is. Next, AJ. Um, these are the pumps that are bringing that water up from the well. Some wells, depends on the depth, could be very, very deep. Some of them can be shallow. Again, it's going to come on, it's going to fill up the pressure tank that we showed earlier, and it's a whole cycle. So just know that if you're on an inspection and you have private water, well water, you're going to see these systems. Next, AJ. Backflow preventers. We talked about that earlier. This is basically just a picture. This is on the water main. This is a backflow preventer that they would put on a hose spigot. Air gap. An air gap is a backflow preventer, because if the supply water is on top and the water on the bottom comes up, there's a gap. It's never going to get into that supply line, because you got that air gap. It'll overflow off of it. And then the picture underneath is just another one. Next, AJ. We talked about the sprinkler system, the backflow preventer. It usually comes off the water main, tees off. You can see that. And on top of that picture would be the backflow preventer from the slide before. Next, AJ. Air gap. That's just a drawing of what we saw as an actual picture. Next, AJ. Condensate drain connection. Again, if it's on a trap and it's not trapped on the bottom, you again, you have the air gap, so the water's never, it's not a closed system, it's never going to push itself back. You can see from that drawing. Pretty straightforward. Next, AJ. Okay, excellent. Solar panels. Solar panels collect energy from the sun. Pump circulates heated fluid. A lot of times you'll see this for a pool. They'll do these solar panels, and they, just like the picture shows, it captures the temperature, the hot water, and it circulates it through it. It could be for a pool. It could be for a hot water tank. You don't see much of it. We see it more as the for heating up a pool. Next, AJ. Okay. Just a little physics real quick. If you increase the pipe diameter, literally what it says, from three to three quarters from half, you're increasing the volume by more than two. So that's just simple math, just something to understand. As you don't have to double the size of the pipe. If you just go up from half to three quarter, you double the area. Next, AJ. Water distribution pipes. This is just copper supply lines, telling you about the thickness, the size. Just an FYI. Compression fittings, that kind of stuff. Go to the next one, AJ. Someone earlier was talking about drains with plated and stuff. So galvanized steel, you're going to look in the water main, make sure it's not a galvanized water main, because obviously it's older. It's going to have, corrosive properties, water flow, low restriction. So those are the type of things you look at when you're identifying the water main supply. Next, AJ. The polybutylene was once widely used for residential water supply. They don't use it anymore. Just be familiar with the types of polybutylene, just ways of identifying it, that type of thing. As an inspector, call it out. Next, AJ. A lot of times you'll see PEX for hot and cold water, for radiant floor heat. So just understand that this is PEX tubing. It's being used uh, a lot now. You'll see it. Just understand that that's PEX. Next, AJ. Um, this is a manifold with water distribution system for individual lines to fixtures. It's kind of a manifold. You see this. We see this every now and then. It kind of controls the flow to the fixtures. Each fixture can have its own shutoff at the manifold. It eliminates the shutoff valves at the location sometimes, but you see this once in a while. Next, AJ. We were talking about water pressure earlier. This is all for the, again, you could see it's the water main because you got the ground wire to the water main. If you have the water pressure is too high, you want to reduce it because you don't want, your fittings and your fixtures to fail because of too much pressure. So you'll see this on the water main. It's adjustable to get the pressure down to um, what you want it to be. Next, AJ. Water pressure, friction, and other factors. Water supply at the fixture is affected by pipe size. We talked about this earlier. Pressure and elevation. That's why as you go up higher, the pressure drops a little bit. Smaller pipes and longer runs increase pressure loss. Change in direction, elbow fittings. High water velocity increases friction in the pipe. That's why you put the pressure regulator on. Next, AJ. Water pressure, velocity, roughness, change in direction, just reiterating what we talked about on the slide before. Next. Elevation, you can go. We talked about that, AJ. Um, again, undersized piping, the the dynamics of going from one size pipe to the other, cross-sectional area. Again, increase, decrease, depending on the pressure size. Just realize 1/2 inch to 3/4 is twice as big. You can go next, AJ. Steel piping as a water supply is not a good thing. It rusts from the inside, restricts the flow. The interior is rough, corrosion, um, lead to leaks. Realize when you have a steel pipe and you start threading it, you can see where you're actually compromising the thickness of that pipe by putting the threads through it. And then a lot of times when you see a pipe that's galvanized or steel as a water supply or water, distribution, you'll see most of the times it'll leak at the fittings and the threads because you just look at the diagram, you can see how you're cutting into the pipe to create those threads. Next. Pipe length, elevation. If there's some dirt in there, it's all going to restrict the flow. These are things that we're talking about with flow restriction. Next, AJ. Water consumption. Uh, Federal standards limit water flow rates for plumbing fixture. Everything is, like we said, energy conservation, conservative, water restriction, and stuff like that. And I think we were talking about it earlier. Sink faucets, right there in the chart. If you see, 2.2 gallons per minute at 60 psi. Usually that's kind of the pressure you want in the house. You might have a little bit higher pressure at the shower head um, to create more pressure because you're taking a shower. But then you have the restrictors. If you have 80 psi there, a lot of times you put the shower heads on that are water conservative. We can go to the next one, AJ. Okay. We kind of touched on this one earlier. Pipe sizing, minimum size of the fixture supply lines, bathtub 1/2 inch, just kind of, yeah, if you see on the bottom comment, we saw that manifold earlier. It can change the dynamics of it, but these are kind of just ideas. Um, to look at. A lot of times when you're looking at the supply lines, depending on the location and the height, sometimes a half-inch pipe, you might not get a good flow, but just kind of keep that in the back of your mind when you're looking at the pipe size. A lot of times the half-inch is not enough to supply, second floor, and you got multiple branches off of that supply line type of thing. But next, AJ. Um, Thermal expansion control, water expands when heated. We talked about that a little bit ago. Increasing pressure in a closed plumbing system. That's why you have this expansion tank. It absorbs the volume like we talked earlier. The air gets compressed as the hot water expands. Backflow preventers or check valves can create closed systems. So that's you'll see that if you look up close, you'll know what that is. Without expansion control, pressure can damage pipes and fixtures. That's why we're doing that. Expansion tanks help protect the water heater and plumbing system. Okay. Next, AJ. Lead content of pipes and fittings. Obviously, lead, you can read it right there. The EPA banned lead. Even in the solder that was used for the copper pipes, there was lead in it. They just started eliminating a lot of that, um, the lead on that. So just be aware of it. Um, Especially at the water main coming in. If you see a lead water main, you have to call it out. Next, AJ. If I'm not mistaken, AJ, what are we at? Like 140 on the slides or so, just to kind of get an idea of the flow. Yep. Okay. Got it. Um, Water distribution pipes. Um, Part of our inspection is going to be to understand what the water main is coming through, and identifying it. They're using plastic coming in now, and obviously copper is very common. Um, some facts about that there. Um, yeah, talk about hot water systems, 180, pretty much straightforward. Next, AJ. Solvents, solvent cement joints, chemically bond plastic. You'll see that on PVC pipes, and stuff. Solder joint is the most common method of joining copper pipes and tubing. Got that. Next, AJ. Galvanic corrosion occurs when two different metals. So you have dissimilar metals. It's going to create um, uh, electrolysis and all of that stuff, and you're going to see corrosion. So just understand you can't have two dissimilar metals. If you do, they put the dielectric fitting in there to keep them isolated, so you don't have that condition. Next, AJ. These are just types of valves. This is a ball valve. Um, it's the easiest one to operate. If someone had to close off their water valve, water shut off. Just there's an example of a ball valve, which is the most commonly used. Next, AJ. Again, just types of shut off valves. Ball valves on the left. Um, uh, Gate valves there, and then the water shut off valve on the right for the toilets. Um, you're shutting them off specifically at that fixture for the toilet. Um, Also for supply lines to appliances and mechanical equipment, different kinds of shutoffs. Next, AJ. Oh, there you go. So you have globe, ball, and gate. So this is just a cutaway section of how they operate. Obviously, the ball valve, quarter turn, it opens itself all the way up. It's like a ball pivoting. The gate valve, pretty straightforward. And then, of course, the gate valve, how it shuts itself down. Just understanding the difference from the mechanical aspect of how they operate. Next, AJ. Hot water. Again, we talked about this earlier. Checking the temperature. It's as simple as maybe using a thermometer like that. document it so you know if it's excessive. You can take a picture and show what it is. And this is someone mentioned earlier on a comment about a tempering valve. These are installed when you have the hot water coming off the coil of a boiler. You'll have it in there because that's how you can adjust the temperature, because you don't have a thermostat. So you'll kind of start mixing a little bit of cold with the hot, those type of things. So if you had a coil in the boiler and you see this, you kind of know what this is. Next, AJ. Um, General comment. So drain, waste, and vent pipes should be properly installed and supported. That's important. Clean out should be accessible for maintenance and inspection. Pipe connection should be secure and free of leaks. Proper slope is required to allow wastewater to flow. Testing helps confirm these. You'll get used to, understanding like the drain lines. If it's pitched too much, then the water's going to flow down quick and the solids are going to be left behind. So you want to understand the pitch, and it causes clogging. Next, AJ. Um, Trenching must provide solid, continuous support for pipes. In other words, they're talking about when you're putting pipes in the ground, you want to make sure they're supported right. The backfill is proper, so when you cover it up, it's not being pushed down into sharp objects. That's basically what we're talking about with trenching. Large rocks or debris should not be placed within 12 inches of the pipe, so you want to have it supported properly. Next, AJ. Um, Septic and cesspools. Um, you have to have a drainage field. This is all part of it. By the way, if anybody's coming down to the convention in Charlotte, that I'm going to be talking about septic, cesspools, and getting into detail about this aspect of what we're talking about now. So if anybody's down there that's on tonight, we're going to be doing it. I'm sure AJ is going to talk about it down in Charlotte, North Carolina. I don't know the dates offhand, but they're going to be live sessions. So if you guys can join us, that would be great. Love to see you, especially if you're on this webinar tonight or the next one I do. I'd love to meet you in person as well. So there's just drainage fields for septic and sewer treatment. You can go to the next one, AJ. Oh, this was an article that was in Newsday recently up by us because of the heavy snow. There was issues with septic and cesspools. They were collapsing. If we had time, I was going to go through this, but you could look it up. And I'm sure if you're in an area where you had heavy snowfall, this was recognized. Next, AJ. Sanitary drain piping. We talked about slope. It has to be proper. The material that they use. Too little slope can cause clogs. We kind of talked about that. Size of the pipes, 2 inches or smaller, require minimum slope of quarter of inch per foot. Kind of getting a lot more detail on that, but it's all stuff you can familiarize yourself with. Go ahead, AJ. Change in pipe side. Okay. Actually, this is we're talking about plumbing. This is a sewer line going out. This is actually from our report. You'll see the guys were running water upstairs, and I was downstairs. And as it was running, water was actually coming out of the trap area. So we had to shut it down. We didn't run any more water because they had a clog in the main line. But that's the pit area you'll see, and obviously you see a new cap there. So we know there was something going on. So obviously we're going to recommend to our client to scope that line. And then you guys and girls are talking about ancillaries. Well, this is a perfect opportunity. You have your camera scope in your vehicle. This is a great time to say, all right, hey, listen, we got a problem here. Let's check out what's going on. So you can kind of plug in your ancillary there. Next, AJ. Again, we're talking about slope drainage. Just be familiar with these sizes. Pretty straightforward. Next, AJ. Change in drain size. Drain pipes should not decrease in size in directional flow. Reducing pipe diameter creates restriction. A lot of common sense. You're just going to look for various drains and pipe sizes that change, and you'll kind of see that it could restrict the flow um, downstream. Next, AJ. Um, Sewer line, cast iron, visual. You're going to look for cracks. This line is exposed in the basement, so you're going to see most of it until it exits the house. Sometimes it's sub slab. You're not going to see it. You're just going to see that the trap, that the picture you saw a few slides ago. You're just going to see those two pieces. You're not going to have the visual inspection like you have on these two pictures. And clearly, this one's rusted and corroded, and that one's cracked. Pretty straightforward. Next, AJ. Um, Different kinds of fittings for horizontal plumbing. Certain ones don't work well, as you can see here, and then the ones with the green check mark is what you want to see. If it's not done right, this is the reason why. Like if you're coming down with a drain pipe, it's coming straight down. You're not directing the flow like you will on the right, where it's kind of a nice sweeping flow. It's not going to back up. This one's coming straight down, and it's just going all over the place. So just understand what you got on that. Next, AJ. Proper joints. Certain plumbing joints are prohibited because they are unreliable and prone to failure. Cement, concrete, and mastic joints are not permitted in modern drainage. Underproof fitting or improper materials can lead to leaks. Common sense. Different pipe materials should not be joined improperly with solvent cements. Again, go back to dissimilar metals and PVC pipes. They got to be um, um, primed properly, and then sometimes they don't even use it. Then they use O-rings. So you just have to know what's going on in your area. Next, AJ. Cleanouts. This is for the main sewer line. You have to have it accessible where you can easily clean it out. So you're going to look for that. You're going to document that in your report. Next, AJ. Drainage system, some pumps and ejector. That's another picture of a clean out. You could go past that one, AJ. Drainage system, sump pumps and ejectors. Know the difference between the two. They're not interchangeable. A sump pump is managing rainwater, an ejector pump is dealing with sanitary waste. So just understand the difference between the two. Understand the components. You need check valves. You need piping, traps, all different kinds of stuff. So you want to make sure. Big thing here is takeaway. Know the difference between an ejector pump, solid waste, sump pump. You're dealing with rainwater, groundwater, that type of thing. Next, AJ. You want to make sure that it's vented properly. Again, these are sump pumps. These are primitive sump pumps. They got groundwater. They're putting it in there. You don't want to do it this way because it's going to clog up the motor. You want to do it the proper way in the ground with the proper drainage and configuration, not like this. Next, AJ. Um, Drain waste vents, you're going to see them. Usually they're coming through the roof on a plumbing stack. Identify it when you're up on the roof. You're going to know that you have a plumbing stack. It's for your plumbing vent for the plumbing. And what that does, obviously, it takes the sewer gases out as well, and it allows understand anytime water flows, you need air behind water. So this is another way to get air to flow and have the water flow properly. If you get gurgling or stuff, it could be a blockage in that. Different types of things. Next, AJ. That's just more pictures. When you're doing an inspection on the plumbing vent, you want to make sure it's sealed properly because this is going into the house. So this is a deteriorated boot flashing on the vent. So you want to make sure that everything's secured, and then clearly that's open. You're going to get water inside. Next, AJ. Air admittance valves, sometimes like on a center island in the kitchen, you're not going to run a vent pipe up through the room into the ceiling in the attic. So they'll put what's called an air admittance valve. You'll see that on certain applications that you want to identify and just say let them know, because sometimes these things can fail and then they have to be maintained, where your main drain vent line, you don't have to deal with that unless it gets clogged, but just let them know that that's there. Point it out, document it. Next, AJ. Um, Vent distances, just numbers that you'll know. A lot of times a visual inspection can tell you a lot of things. I don't know if you're going to start taking out and start measuring things, but just you have an idea. It's good chart to know. Next, AJ. Termination points. Vents typically terminate through the roof to release sewer gases safely. We talked about that a little bit. Proper vent terminates allow air into the system to prevent pressure problems. Vent openings should be clear and free of debris. Damage of vent caps can allow debris or animals into the pipe and into the attic if it's not sealed properly. And those are the things we check for when we're doing an inspection on that. Next, AJ. Okay. Traps. Um, Plumbing traps hold water to create a seal that blocks sewer gases. That's the reason why you have a trap, so you don't get the smell of sewer gases back into the house. It's clearly trapping water. That's why they call it a trap. You eliminate sewer gases coming back into the house. Toilets have traps built into it. That's why you see that cutaway view there. Proper venting is required to prevent traps from being siphoned. Um, Go to the next one, AJ. Again, just pipe sizes. There was a slide on this previous. Um, Pretty straightforward. Next, AJ. Okay, so certain traps that you don't want to come across, um, because they can lose their water in the trap and defeat the purpose of it. Certain traps designed, S traps are not allowed because they can siphon the water out of the trap and allow the sewer gases to get into the house. So if you're on an inspection and you're looking underneath the cabinetry, the sinks and stuff, always call out an S trap for that simple reason. You want to see the conventional P trap, which comes down. We talked earlier about the tailpipe on top, then it goes through the trap, and then it's out into the line. But again, if you look at this illustration with the green check mark, you see that the water is being trapped in that trap to prevent the sewer gases. Um, Go to the next one, AJ. Trap cleaner. Definitely got to get better pictures in here, AJ. um, the trap clean out. Yeah, you want to be able to clean that trap in case sediment or debris or your ring goes down there. You can open it up and pull it out. But obviously, this one you're gonna call out as it's broken. Go ahead, AJ. Yep. Okay. So if you do what's called phase inspections and you go through the various stages, you get called in to do different inspections at different phases. You'll see a lot of the plumbing that's and even the wiring. They have the plates in the front. You got to make sure that no nails or screws can go through it. So that's the idea: protection against pipe damage in studs. Um, Protective metal nail plates are often installed where pipes pass through the framing, That's the illustration of the studs here. When you're doing a phase inspection, obviously you can't see behind the wall if the wall's already up. But if you're doing a phase inspection, you're gonna look for these things during your inspection. Next, AJ. Um, Again, charts to kind of understand how things are strapped. Plumbing pipes must be properly supported to prevent sagging or movement. Support spacing depends on pipe material and pipe size. Obvious horizontal piping requires special reports and supports and hangers. Same thing when we're talking about that dissimilar metals. You don't want to support um, the drain pipes with metals that would be corrosive. Just the fact that they're dissimilar metals, you want to call that out. Sometimes you'll see rubber gaskets underneath it to keep it from um, uh, causing that galvanic reaction with the dissimilar metals. Um, you can go next, AJ. Okay, so as you're doing inspections, this is in a crawl space. If it's improperly supported, we're talking about support systems um, for the drain. Cast iron is pretty heavy. You want it supported properly. When you're looking in the crawl space and you see this, obviously you're going to call it out in improperly supported. So again, a lot of visual. Next one, AJ. Storm drain basics. Um, what are we at? One. Uh, Storm drain should remain. Yeah, we talked about that earlier. Exterior drains, you want to make sure they're clear of debris and everything's sloped towards it to drain properly. But we always put in a report on exterior drains to allow for proper drainage. Next, AJ. Um, Same thing with the downspouts. You want to make sure they're pitched properly, away from the house. Storm drain should remain clear of debris. We said that again. Blockage grading. You want to make sure the gutters are going down the right way, and clearly, the gutters are not clogged as you're doing in your inspection. Next, AJ. Okay, dryer vents. Pretty basic. If it's clogged and dirtied or disconnected, plastic dryer vents, call them out. They're fire hazards. You want to make sure everything's flowing up and out properly. um, Good illustration, visual type of thing. Next, AJ. Dryer length, again, depending on the length and the turns. If there's a lot of turns and twists, it's going to clog. You're going to call that out, the termination point. Next, AJ. Connection, you're always going to look for the proper connection from the dryer to venting it outside. You don't want to see it venting into the attic or the basement or the crawl space. It's just going to create moisture and not a good thing. So that's the whole idea with dryer termination, to know where it is. Next, AJ. We talked earlier about fuel storage. Again, this is an oil tank in the basement. It's clearly rusted and corroded. You're going to call it out. When you see the pipes outside, you're going to, the fill in the vent, you call it out. You explain it to your clients. Again, this is a tank in the basement, rusted, that kind of stuff. You're going to call it out. Next, AJ. Um, Again, just the illustration of the oil tank system, the fill, the vent, the supply lines, the shut off. The fill pipe allows delivery of oil into the storage tank. The vent pipe releases the air. Supply lines carry oil from the tank to the furnace or the boiler. Um, you want to check the valves, leakage, rust, just like we did on the previous slide. Next, AJ. Some oil tank defects. Again, corroded, rusting, leaking, shutoff valve, oil gauge damage. This is a good illustration of things to look for when you're doing your oil tank inspection. Next, AJ. Underground and support for flue gases, pipes. Again, it's back to the supports. Make sure that the vents are supported properly. Um, Pretty straightforward there. Next, AJ. Fuel gas sediment trap. That's on the bottom of the gas supply to the fixtures. You'll see that little um, piece on the bottom. Next, AJ. That's improper. It's not in the right spot. Just an illustration of it, and that's the proper application on the illustration on the right. Next, AJ. 126. So, fuel sediment trap, same thing. This is with a flexible connection. Again, you have to have the trap on the bottom. Next, AJ. Fuel shut-off valves. We talked about that earlier. They're going to be at the on all the appliances. Next, AJ. Um, Gas appliances. You want to make sure that there's proper shutoffs at the appliances. Um, Flexible connectors. They allow movement when the appliances are moved front and back. Connection must remain visible and accessible for inspection. They should not pass through walls, floors, or ceilings. Pretty straightforward. Next, AJ. Fuel venting. You're going to check the venting system, make sure there's no corrosion on the pipes, that kind of stuff. Again, just visually, you're going to see things. Just look, you'll find things as you're looking and report on them. Report on it exactly as you see it. Next, AJ. Insulation shields. Um, Insulation shields keep combustion away from vent pipes and chimneys. So when you're in the attic, all the insulation is not up against that chimney pipe or venting of a hot appliance. Fire stops help prevent the spread of fire between building levels. So that's the fire stop right around it. Um, we're going to check, make sure the insulation's not touching the vent or the chimney. That's pretty straightforward. Next, AJ. Um, Factory built chimneys and flue gas, commonly used on gas fireplaces, furnaces, and heating appliances. Proper flashing at the chimney cap prevents water intrusion. These are things you're going to look at when you're inspecting these type of appliances. Next, AJ. Chimney connection. You want to see where the boiler, the furnace, the water heater, how it's connecting to the chimney at that spot. You want to make sure it's properly sealed. You want to make sure that there's no corrosion, that it's slightly pitched going up. Don't miss that. If you see a down pitch on these vents, call them out. Just visually, if you got a little level that you can put on it to kind of give a visual for that, that's important. That's where the vent connector goes into the chimney. Um, Obviously, the smaller appliance is always on the top, bigger appliance on bottom. Go to the next one, AJ. Fuel gas vent termination. This is just areas that flue gas vents are terminated. Proper clearance is required from doors and windows. Vents termination should be positioned to prevent exhaust from re-entering. You don't want it near a window. Good diagram. All these illustrations are from InterNACHI. So if you go on, you'll see all of these and you can study and take the courses as well. Next, AJ. Clearances. Clearances for fuel gas. Fuel gas vents must terminate above the roof at specific heights. Clearance depends on the roof pitch and distance from nearby structures. Proper heights ensure safe draft and prevent downdrafts. Vents should terminate away from the roof surface and obstructions. All things you look for when you're doing an inspection. Next, AJ. Chimney, masonry, fireplace. You got the 2 in 10 rule. You should be familiar with that. Chimney must be at least 3 feet above the roof. Again, illustration says it all. Get familiar with it, understand it, learn it. Next, AJ. Okay. Automatic dampers control airflow. Um, in a fuel gas vent system. They open when the appliance operates and closes when it shuts off. This helps improve efficiency and reduce heat loss up the vent. So it's an automatic damper. It's installed in the vent connector above the appliance. Those are things you look for. Make sure that the doors uh, move properly and they operate freely without obstruction. Next, AJ. We talked about that slide. You could flip past that one. Um, this is just factors affecting water supply. We talked about it earlier. This is just a good visual: height, pressure, number of changes in direction, smoothness of the inside of the pipe, and of course, pipe size. Next, AJ. Um, Copper pipes, different types. You'll see them imprinted on the copper. Just familiarize yourself with them and what they're used for. Next, AJ. And this is what we were talking about earlier. You don't want to have dissimilar metals to cause corrosion. You don't want to have a copper pipe with a steel hanger. Same thing with the nail. That type of stuff. Um, I believe that's the last slide. So if you want to go back to that, again, that's who we are. If you take a picture of the QR code to give you my information, feel free to get in touch with me. Um, Shoot me a text. Be more than glad to help anybody out if they're in our area. Phone call, a text is the best. I can always respond back to you.